Welcome class 8. Class 8, I hope you all are well. So today we are going to continue same chapter, that is chapter light. So children, we have already studied till the difference between the real image and virtual image in the last lecture. Okay, today we are going to study topic ray diagrams. So children, as you know that the image formed by a plane mirror is erect, virtual and is of same size as that of the object. Yes or no children? Whatever the image which is formed by a plane mirror, okay, the image formed by a plane mirror, or you can say flat plane mirror, it is what are the properties of the image which is formed by the plane mirror? They are erect, virtual, okay, and is of the same size as that of the object. Erect means exactly the same, सीधा image, okay. एकदम like if you are holding something, तो exactly the same image you will find erect, okay, not upside down, okay. Erect means सीधा एकदम in the right position. Then virtual means the image cannot be captured on the screen. And third is the image formed by the plane mirror is of same size as that of the object, okay. Whatever will be the size of the object, same will be the size of the image formed by a plane mirror. So these are the three properties of the images which are formed by a plane mirror. That is, the image is going to be erect in case of a plane or flat mirror. Erect means exactly सीधा, उल्टी image नहीं बनेगी, सीधी image बनेगी. Virtual means image cannot be captured on the screen. Yes, as soon as you are away from the mirror, or mirror is removed from in front from your where you are standing, so what will happen? Your image will also be removed, or image will vanish, and the size of the image will be of the same size as that of the object. But if we talk about children, spherical mirror means they are concave mirror or convex mirror. So the images formed by spherical mirror depends upon what points? That are, number one, nature of the mirror. Okay, the image formed by a spherical mirror or curved mirror, it depends upon the nature of the mirror. Means what is the nature of the mirror? Okay, whether it is convex or concave. Secondly, distance of the object from the pole of the mirror. Okay, what is the distance of the object from the pole of the mirror? Means whether the object is near to the pole of the mirror or it is away from the pole of the mirror. And third point is the focal length of the mirror. Now I have already explained you about the focal length, that what is the focal length of the mirror. Yes, it is the distance between the pole of the mirror, and principal focus or focal point. इनके बीच का जो distance होता है, this distance is known as your focal length. So what are the 3 points on which the nature of the image formed by spherical mirror? Either it is convex mirror or concave mirror. So it depends upon the nature of the image formed by spherical mirror, depends upon 3 points. Number 1, nature of the mirror. Number 2, distance of the object from the pole of the mirror. Means what is the distance of the object from the pole of the mirror? This is the pole of the mirror. तो object किस distance पे है? And the third thing is the focal length of the mirror. Now children, the exact nature and size of the image formed by the objects kept at different position in front of spherical mirror can be determined by tracing the path of the light by drawing a simple diagram, and such diagram is known as ray diagram. Now children, if we are going to see that how does the image, or you can say what is the nature or size of the image when the object is kept at different position from the pole of the mirror. Okay, we are going to determine this thing. So how we are going to determine? We are going to determine with the help of the ray diagram. Means with the help of using the rays, we are going to determine that how does the image of different shape and different size and nature is formed when the object is kept in front of the spherical mirror. Okay, now children, in ray diagram the object is represented by a vertical arrow. For simplicity, it is kept perpendicular to the principal axis such that its foot touches the principal axis. Now you can see children here, just wait, you can see here, this is your which mirror? See, inner side is reflecting, outer bulging side is coated or silvering is done. So this is your concave mirror. So it is said, children, ki now we are going to determine how does the objects or different objects when kept in front of the spherical mirror, how does the images form at different position? What are the nature of the images? Okay, so children, first of all, how does we represent the object in ray diagram? Object we represent by this simple arrow which is kept like this. Suppose हमें इसकी image निकालनी, ये object है, इसका image निकालना है, तो हम ray diagram में how do we represent the object? By simple perpendicular line. You can see like this. This is your principal axis. Inner side is your reflecting surface and outer side is coated or silvering is done. Now construction of images using ray diagram. Now one thing more, children, that when the object is kept, okay, many rays emerges from the object. Object से बहुत सारी rays आती हैं और object पे कहाँ से rays आती हैं? Either from the sunlight or by artificial light. Okay, suppose you are standing in front of the mirror. So it means your body, from your body many rays will go. Okay, but from where these rays are coming on your body. So your body will receive these rays either from the sunlight or by artificial light. So this is the object. So object, it is given here that you know that infinite number of rays travels from any point of an object. Object से बहुत सारी rays pass होंगी. But for making a ray diagram, or you can say for our convenience, we are only going to take 2 rays. Okay, so children, this ray diagram part is very important. Okay, do not ignore this. If you will understand this thing, then only you are going to able to make the diagrams. Okay, now first is, what is the first rule for drawing a ray diagram for any object when kept in front of the spherical mirror? An incident ray, number 1 is an incident ray passing through the center of curvature. Now children, you can see, just look at the diagram. This is the concave mirror. Inner side is reflecting, outer bulging side is coated, and this is your convex mirror. Here inner side is coated and outer side act as the reflecting surface. So children, it is said that if any rays passes through, or if any ray passes from center of curvature, you know, this is the pole of the mirror, this is principal focus or focal point, and this is center of curvature. So it is said, children, that if any rays passes from, or if you say any ray pass from center of curvature to the reflecting side of the mirror, it deviates back. मतलब reflect होने के बाद उसी path पे वो ray वापस आ जाती है. You can see from the diagram, children, that you can see this arrow, that first of all this ray is moving like this, and after reflection it is again getting back, or you can say it is retracing its path on the same center of curvature. अगर कोई ray center of curvature से जा रही है and after reflection it will again pass, or again after reflection it will pass from center of curvature. Okay, so if any ray travels or if any ray travels from center of curvature, so after reflection it will again deviates back from same center of curvature. Reflection के बाद center of curvature से दोबारा वापस जाएगी. Okay, this was case of your concave mirror. But if I talk about convex mirror, children, so in convex mirror you can see here also, suppose this ray is coming like this, you can see here the ray is coming like this. So arrow is this side. Now after, you know that in convex mirror outer side is reflecting surface. So after reflection it will again get back, उसी पाथ पे वापस चली जाएगी. बट वी विल सी, हमको ऐसा लगेगा इफ वी आर गोइंग टू एक्सटेंड दिस रे बैकवर्ड, तो वो कहां पर जाके मिलेगी? सेंटर ऑफ कर्वेचर. सो वी एज अ ऑब्जर्वर वी विल फील दैट द रे इज कमिंग फ्रॉम सेंटर ऑफ कर्वेचर. So this is the case of concave mirror and this is the case of convex mirror. And same thing is written here, that an incident ray passing through center of curvature of concave mirror reflects back along the same path without any deviation. अगर कोई ray center of curvature से जा रही है, so after reflection it will move back on the same path. Okay, it will not deviate anywhere, any other path. It will move back along the same path. Okay, so this was the case of your concave mirror and this is the case of your convex mirror. Convex mirror में क्या होता है? In case of convex mirror, an incident ray appear to move towards the center of curvature, is reflected back along the same path without any deviation. इधर उधर deviate करने के बजाय it deviates back on the same path. You can see the ray is coming like this. Now after reflection, you can see it is deviating back on the same path. उसी path पे वापस चली जाती है reflect होने के. And when we are going to extend this ray backward, so we will assume that हमको ऐसा लगेगा, we will feel like that this ray is coming from where? Center of curvature. So this is the case of convex mirror and this is the case of concave mirror. Now what is the rule 2? Rule 2 says, so I hope this thing is clear to you, कि if any ray passes from or if any ray incident on the spherical mirror which is coming from center of curvature, so after reflection the ray will move back along the same path, and this thing is valid for both the mirror, concave mirror as well as convex mirror. Now the next thing is, children, that an incident ray parallel to the principal axis. Now suppose, children, in case of concave mirror, an incident ray parallel to the principal axis. Now suppose, children, if any ray is coming parallel to the principal axis, this is your principal axis and you can see this ray is coming parallel to the principal axis. So if any ray is coming parallel to the principal axis, ये देखिए आप red color की ray parallel आ रही है principal axis से, so after reflection it always and always passes through principal focus or focal point. Reflection के बाद it always passes from focus. Okay, principal focus or focal point. You can see the ray is coming like this and after reflection it is passing from principal focus. So this is the rule. Now in case of convex mirror, you can see here the ray is coming like this parallel to the principal axis, and after reflection you can see it will reflect like this, and it appears after reflection, in case of convex mirror, it appears that as if the ray is coming from principal focus, because if we are going to extend this ray backward, हमको ऐसा लगेगा that this ray is coming from principal focus. So this is the case of convex mirror, this is the case of concave mirror, and same thing is written here that in case of concave mirror, an incident ray parallel to the principal axis passes through its focus after reflection. You can see an incident ray parallel to the principal axis, this red color ray parallel to the principal axis after reflection. Do remember, अगर कोई भी ray जो parallel है principal axis के, after reflection it always passes from focus in case of concave mirror, and in case of convex mirror, an incident ray after reflection appear to come from the focus of the mirror. Okay, हम appear to, हमको ऐसा लगेगा in case of convex mirror it appears to come from the principal focus, and in case of concave mirror it passes from principal focus. So I hope, children, these two rules are clear to you, that if the ray is passing from center of curvature, so after reflection the ray will deviate along the same path, means again after reflection it will pass along the center of curvature in case of concave mirror, and in case of convex mirror it appears to the ray after reflection appears to come from the center of curvature. And the second rule is that if any ray is parallel to the principal axis, so after reflection it passes through principal focus, and in case of convex mirror it appears to, the ray after reflection appears to come from the principal focus. So I hope, children, these two rules are clear to you. Now coming to next rule. What is the next? An incident ray passing through the focus. Now the next rule is, suppose if any ray is passing through the focus, this is the third rule. Okay, then only, children, if all these rules will be clear to you, then only you will be able to make the ray diagram, which is very important for your exam purpose. So it is said, children, the third rule is that if any ray, अगर कोई incident ray कहाँ से आ रही है, it is coming from principal focus. Okay, if any ray is coming from incidenting from principal focus, so after reflection it becomes parallel to the principal axis in case of concave mirror. You can see here that this incident ray is coming from principal focus. फोकस से अगर कोई रे फोकस से पास हो रही है तो रिफ्लेक्ट होने के बाद वो क्या हो जाएगी, पैरेलल हो जाएगी पैरेलल किसके हो जाएगी, प्रिंसिपल फोकस के. दिस इज द केस ऑफ कॉन्केव मिरर. बट इफ आई टॉक अबाउट कॉन्वेक्स मिरर चिल्ड्रन, सो कॉन्वेक्स मिरर हेयर ऑल्सो इफ एनी रे अपीयर्स, अगर हमें ऐसा लग रहा है कि कोई रे आ रही है जो प्रिंसिपल फोकस से पास होना चाहती है, but because as you know this is the convex mirror, so here the ray will reflect outside only, so it will reflect in such a manner that we will assume that this ray is passing from this ray is or you can say in this case this ray appears to move in the direction of principal focus of the mirror. Okay, same thing is given here children, that in concave mirror an incident ray passing through the focus is reflected parallel to the principal axis. अगर कोई रे प्रिंसिपल फोकस से पास कर रही है तो रिफ्लेक्शन होने के बाद इट विल बिकम पैरेलल टू द प्रिंसिपल एक्सिस. Whereas in case of convex mirror, the incident ray which appears to move in the direction of the focus of the mirror, you can see this ray appears to move in the direction of the principal focus. Okay, in the direction of the focus of the mirror is reflected parallel to the principal axis. So अगर convex mirror है, if any ray appears to move in the direction of the principal focus, so after reflection it becomes parallel to the principal axis. ये वाली रे हमें लग रहा है जैसे इधर से आ रही है तो हमें लग रहा है it is going to pass through principal focus, but after reflection it becomes parallel to the principal axis. Whereas in case of concave mirror, you can see if the ray is becoming parallel to the principal axis, if the ray is passing from principal focus, so after reflection it becomes parallel to the principal axis. And in case of convex mirror, if any ray appears to come in the direction of the principal focus, after reflection it again becomes parallel to the principal axis. So I hope children this rule is also clear to you. Now coming to next rule, a ray of light incident at the pole of the mirror. Now suppose children what happens, a ray of light is incidenting in such a manner that it incident at the pole of the mirror. So what will happen? अगर कोई ray of light pole of the mirror पे incident कर रही है, if any ray of light is incidenting at the pole of the mirror like this ray is incidenting at the pole of the mirror, so after reflection it will follow which law? Laws of reflection. Means here if any ray is incidenting at the pole of the mirror, then that time the ray of light after reflection will follow which law? Laws of reflection. Laws of reflection means angle of, in that case after reflection angle of incidence will be equal to angle of reflection. अगर कोई light pole of the mirror पे incident कर रही है तो reflect होने के बाद it will follow which law? That is your law of reflection. And what happens in law of reflection? Angle of incidence will be equal to angle of reflection. Okay, a ray of light incident at the pole of the mirror in a concave mirror, a ray of light incident at the pole gets reflected along a path such that angle of incidence is equals to the angle of reflection, and this is also true for the convex mirror. So you can see here if any ray incident at the pole of the mirror, in this way you can see here from the diagram, so after reflection it will reflect in such a manner that it is going to follow which law? Laws of reflection, and here the angle which is going to be made, that will be assumed as normal, and here the angle of incidence will be equal to angle of reflection, and same thing is followed in case of convex mirror. So I hope children this thing is clear to you. Okay, so the rule number 1, as you know, this is the pole of the mirror, this is the principal focus, and this is the center of the curvature. Okay, center of the curvature, principal focus, or you can say focus, pole of the mirror. So rule number 1 says that if any ray passes from center of the curvature, so after reflection it will deviate back, it will follow the same path. Okay, and in case of convex mirror, if any rays appears to follow the path along the direction of the center of curvature, so after reflection again it will follow the same path. Okay, now if any ray is coming parallel to the principal axis, so after reflection in case of concave mirror it passes through principal focus. Okay, whereas if any ray is coming parallel to the principal axis in case of convex mirror, so after reflection it will reflect in such a manner that our reflected ray appears to come from the focus of the mirror. ऐसे reflect करेगी कि हमें लगेगा जो हमारी reflected ray है वो focus of the mirror से आ रही है. Okay, then is your third rule, An incident ray passing through the focus of the mirror. Suppose if any ray is passing from the focus of the mirror, so after reflection it will become parallel to the principal axis. And here if any ray is coming in the direction of the principal focus in case of convex mirror, so after reflection it will again become parallel to the principal axis. Now the last rule, if any ray incident at the pole of the mirror, so after reflection it will reflect in such a manner that it is going to follow which law? Laws of reflection, that is angle of incidence will be equal to angle of reflection. So I hope children all these things are clear to you. Do read this chapter, otherwise it won't be clear to you. Okay, now let me discuss these exercise also. Number 1, true and false, and the first is a concave mirror is also known as diverging mirror. False. Why children? Because as you know that in concave mirror after reflection all the rays they converge at which point? Principal focus. Okay, so concave mirror is not a diverging mirror, but it is which mirror? It is a converging mirror. So just correct this, just cut this diverging and write down converging, and this statement is false. You can see from this rule also that if any ray is coming parallel to the principal axis after reflection it converge at which point? Principal focus. All these things I have already explained you children. Now the next thing is the focal length of the spherical mirror is twice the radius of curvature. Is this focal length children? This focal length, as you know the distance between the pole of the mirror and principal focus, this is focal length. Okay, distance between focus and pole of the mirror is your focal length. So it is said the focal length of the spherical mirror is twice the radius of curvature. क्या ये radius of curvature का twice है focal length? No. Focal length is half of radius of curvature. Radius of curvature is your this distance. Yes. The distance from center of curvature to the pole of the mirror is your यहाँ से लेके यहाँ तक आपका radius of curvature है. Okay, from center of curvature to pole of the mirror. Okay, and what is your focal length? Focal length is from principal focus to pole of the mirror. So focal length is not twice, but it is half of the radius of curvature. So this statement is also false. While sketching a ray diagram, the object should always be kept in front of the polished surface. Are we going to get the image in front of the polished surface? No, false. We get the image in front of the reflecting surface. So this statement is again false. Okay, a ray of light incident at the pole of the spherical mirror is reflected along a path making the same angle with the principal axis as the incident ray does. True, I told you this law. If ray of light is incidenting at the pole of the mirror, then the angle of incidence will be equal to angle of reflection. So this statement is true. This statement is true. Now fifth one, a ray of light parallel to the principal axis after reflection from the concave mirror will pass through the center of curvature. False. I told you that in case of concave mirror, a ray of light parallel to the principal axis, you can see here, a ray of light parallel to the principal axis after reflection it passes through principal focus, not center of curvature. So this statement is again false. You can just pause